Dear students, in JEE 2024 Phase 1, this question was from chapter Current Electricity. Question is, two conductors have the same resistances at 0 degree Celsius, but their temperature coefficients of resistance are alpha 1 and alpha 2. The respective temperature coefficients for their series and parallel combinations are what? Options are 1. Alpha 1 plus alpha 2 and alpha 1 plus alpha 2 by 2. 2. Alpha 1 plus alpha 2 by 2 and alpha 1 plus alpha 2. 3. Alpha 1 plus alpha 2 by 2 and alpha 1 plus alpha 2 by 2. 4. Alpha 1 plus alpha 2 and alpha 1 alpha 2 upon alpha 1 plus alpha 2. Now see here, it is given to you two conductors have the same resistance at 0 degree Celsius. And their temperature coefficient for resistances are alpha 1, alpha 2. So we have to find the equivalent or resultant temperature coefficient for their series and parallel combinations. Now see, let's start for first series combination. See here, we have the equation for the resistance at any temperature T, that is equal to R equal to R0 1 plus alpha delta T. R0 is the resistance at 0 degree Celsius. So delta T, that is T minus 0. So we can write R equal to R0 1 plus alpha T. Now we have two conductors. Both have same resistance at 0 degree Celsius, but their temperature coefficients are different, alpha 1 and alpha 2. Therefore, their resistances at temperature T will be R1 equal to R0 1 plus alpha 1 T and R2 equal to R0 1 plus alpha 2 T. Now in series combination, if we take here series combination of these two conductors, then their resultant resistance at 0 degree Celsius will be 2R0. So here we can write R equivalent, that is R1 plus R2. Okay, at any temperature T. Now at temperature T, R equivalent, that we can write R equivalent equal to resistance at 0, that is 2R0, 1 plus alpha equivalent into T. We want to find this alpha equivalent. Now in this equation, R equivalent equal to R1 plus R2. Substitute the value of R equivalent, this R1 and this R2. So we will get 2R0 into 1 plus alpha equivalent into T equal to value of R1, that is R0 into 1 plus alpha 1T, plus value of R2 at temperature T, that is R0 into 1 plus alpha 2T. So R0, R0, R0 will be cancelled from both the side. And now simplify this one. We can write 2 plus 2 alpha equivalent T equal to 1 plus alpha 1T plus 1 plus alpha 2T. This 1 plus 1, 2, and these 2 will be cancelled. Then take T common, it will be cancelled. So we can write 2 alpha equivalent equal to alpha 1 plus alpha 2. So alpha equivalent, that is alpha 1 plus alpha 2 by 2. So alpha equivalent for series combination of these two conductors is obtained. Now let's think about parallel combination. So in parallel combination for both the conductors R0, R0, the resultant at 0 degree Celsius or equivalent resistance at 0 degree Celsius will be R0 by 2. So here we can write at any temperature T, for parallel combination of these two resistances, we can write 1 upon R equivalent parallel, that is 1 upon R1 plus 1 upon R2. Now R equivalent parallel that we can write. R equivalent equal to resistance at 0 degree Celsius, that is R0 by 2, 1 plus its alpha equivalent at temperature T. Now, in this first equation, 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. Substitute the value of R equivalent and R1 and R2. So 1 upon R0 by 2 into 1 plus alpha equivalent into T equal to 1 upon R0 into 1 plus alpha 1T plus 1 upon R0 into 1 plus alpha 2T. Take R0 common from both the side, will be cancelled. These two will be taken in numerator. So 2 upon 1 plus alpha equivalent into T equal to 1 upon 1 plus alpha 1T plus 1 upon 1 plus alpha 2T. Now, take LCM on right hand side. So left hand side as it is, 1 plus alpha 2T plus 1 plus alpha 1T upon 1 plus alpha 1T into 1 plus alpha 2T. Now, take a cross product. So here, simplify this one first. So 2 upon this one as it is on left hand side, right hand side is simplified. 2 plus alpha 1T plus alpha 2T upon 1 plus alpha 1T plus alpha 2T plus alpha 1 alpha 2T square. Now, cross product. So 2 plus 2 alpha 1T, this cross product. 2 alpha 2T plus 2 alpha 1 alpha 2T square. And this one on right hand side. 1 plus alpha equivalent T into 2 plus alpha 1T plus alpha 2T. Now, alpha 1 and alpha 2 are very small. Therefore, alpha 1 into alpha 2, that will be very, very small. So we can neglect this one. So we can rewrite 2 plus 2 alpha 1T plus 2 alpha 2T equal to 1 plus alpha equivalent T into 2 plus alpha 1T plus alpha 2T. Okay. Now, again here, if we simplify right hand side, then 1 into 2, 1 into alpha 1T, 1 into alpha 2T. Then 2 into alpha equivalent T. But then again, alpha 1 into alpha equivalent and alpha 2 into alpha equivalent are very, very small. So directly neglecting it. Okay. Now, these two and these two will be cancelled from both the side. And then after, if we take T common, then T will be cancelled. Then 2 alpha plus 2 alpha 1 plus 2 alpha 2 equal to alpha 1 plus alpha 2 plus 2 alpha equivalent. So if we take alpha 1 alpha 2 on this side, directly we can write here alpha 1 plus alpha 2 equal to 2 alpha equivalent. So alpha equivalent for parallel combination, that is alpha 1 plus alpha 2 by 2. So as per given option, our answer is 3. Clear?